Okay, the next topic is just about how to find the solution for the first order differential equation. So usually the general form of this type of differential equation in this term, dy by dx is a function of f x y. So this one is different from the example that I used to give to you in the previous class, right? Because for that one is dy by dx function of x only. So you just use the integral technique to find the solution of that type of equation. But this one is different in the sense that instead of dy by dx is a function of x only, it becomes a function of x and y. In this case, the way to find the solution, you've got to try to arrange the equation itself in one of either these forms. The first one is called separable equation. The second one is homogeneous equation. The third one is exact equation. The fourth one is linear equation. The fifth one is Bernoulli equation. And the last one is called Riccati equation. So your first order differential equation can be either form of this, one of this, or can be one or two from this. So it just depends. Each type of equation, they have the way to find the solution of the equation in different ways. Okay. So I'm going to teach you like in order. The first would be the separation equation. How would we call separable equation? But it's going to follow like this. Okay. You've got to arrange your first order differential equation, this form, to be either one of these. That is the tough part because sometimes it's quite difficult for you to arrange the equation, but if you're practicing a lot, like find the book, find the problem statement from another math book, and try to solve for the answer. Try to arrange the form of each differential equation. I mean, like, the more you practice, the more you gain the knowledge and you know how to solve differential equations. Okay, let's take a look at the first type of differential equation, which is called separable equation. The separable equation is just in the form, like I said that when you have dy by dx is equal to function of fxy. If your function of fxy is in this term, gx and time with py, it means that you can separate x and y from each other. Then in that case, it's called separable equation. Why it's called separable equation? Because if you can arrange it in this form, you can put dx with x and py with y, like this. From this, on your left-hand side, it's a function of y only, and your right-hand side is a function of x only. So in this case, you can do integral right away. Okay, just put the integral there. That would be the answer. Let's take a look at the example. You have dy by dx is equal to 2x plus xy divided by y squared plus 1. With this differential equation, can we do it as the separable equation. If you take a look at this, the term on the top, you can take x out, right? When you take x out, inside you've got 2 plus y divided by y squared plus 1. See, you can separate y function and x function out of each other. So in this case, it's comparing to our general formula right there. We would say dx is equal to x and py is equal to 2 plus y divided by y squared plus 1. Right? Then what do we do next? Can we do the integral by putting x with dx and the function of y with dy? Okay, we do that, we would get y squared plus 1 divided by y plus 2 dy is equal to x dx. Right? Now, on your left hand side, you have only y. And on your right hand side, you have only x. So in this case, you can do integral because the left hand side you integral with y and the right hand side you do integral with x. Okay. Then we do integral. How do we do the integral on the left hand side? The term on the top have the higher power than the term on the bottom. So we've got to do what? Dividing first, right? We do it until the top have less power than the bottom. Okay. We do the dividing. What time y equal to y squared? Y, okay? What time y is equal to negative 2y? Minus 2, right? So now 5 is 5 times y to the power of 0. So it's already less than that y. Then we would get y minus 2 plus 5 divided by y plus 2 dy. Now can you do the integral of this term? If it go like this, can you do the integral of this term? You can use the distribution property. So you would get integral y dy minus 2 integral dy plus 5 integral y over y plus 2 dy equal to integral of x dx plus 6. Integral of y dy is equal to y squared divided by 2 integral dy is equal to y. You've got negative 2y plus y. Integral 1 over y plus 2 dy. You make this dy to be dy plus 2. So you got ln y plus 2 equal to integral x dx x squared divided by 2. Consider another example. equation, we arrange it to be a separable equation? Can we? First, we write down dy by dx first. Yes. We would get dy, x squared y squared minus 3 times dy is equal to x minus 2 y to the power 3 dx, right? Because this is minus, you move it to the right hand side, you get plus, right? We are going to write down the term of dy by dx, so we would get dy by dx, you move dx here, divided dy. Then you're going to move this term to the right hand side, you would get x minus 2 y to the power 3 divided by x to the power 2 times y squared minus 3. Now, can you write down the gx and py? What is your gx? Gx is equal to x minus 2 divided by x squared, right? And our py is y to the power 3 divided by y squared minus 3. So it's a separable equation, right? Then the way that we do it is just put the function of y with dy and put the function of x to dx. So we would get right? Now, your left hand side is a function of y only, and your right hand side is a function of x only. In this case, you can do the integral. To do integral of this term, sometimes you know what would be the method to find the solution of this equation, but you will start on how to do integral. That's why I just asked that to go review the integral technique. Okay, so with this one, because the dividing term is a y to the power 3, the way that you can do is you separate into two terms, like this. By using the property of fraction, right? When you do the summation or minus of the fraction term, if you have the denominator, I mean, if both terms have the same denominator, you can do plus or minus for numerator. So I just do the reverse of that property, that in that case we can separate it into two terms, right? These two terms you can sum it because you have the same denominator term. So sometimes you write it this way. Okay. But this one, if we do integral of this one, is hard. So the way that I do it is do reverse of that property, separate them out to be each term like this, and then we will get the first term, we will get 1 over y, right? Y squared divided by y to the power 3, we will get 1 over y. go like this because we also use the distribution property of the integral term. Okay? And the first term of this one we would get 1 over x. Right? Okay. The first term, what would you get when we do the integral? Integral of 1 over y dy is equal to ln y. Integral of 1 over y to the power 3 dy is equal to right? Which is equal to 1 over x dx is ln x. 1 over x squared dx, we do integral is equal to minus 1 over x. Minus and minus become plus. Just that.